just a couple of other formulas that can be handy. So the first one, the perpendicular distance formula, because whenever we're asking for, what is the distance from a point to a line, obviously there's infinite number of different answers depending on which direction you go. It's sort of implied they're talking about the perpendicular distance from the point to a line, the shortest distance. There's a point, x1, y1, to some line. Now for this formula, the general form of the line becomes the useful way of writing the equation. So what is that distance? Well, there's our formula. Basically it comes from Pythagoras' theorem again. You could draw a right angled triangle in there and create this equation. So we have the absolute value on the top, and that's why general form's useful, because essentially it's just the general equation, but you substitute in the values x1 and y1, and then on the bottom it's Pythagoras' theorem with the coefficient of x and y. We'll do this example. We're going to find the equation of the circle which has that tangent, and the centre of the circle is 1, 4. Alright, so there's my circle, that's 1, 4. It's a tangent, and we know the radius is perpendicular to the tangent, so effectively what we're essentially finding is the perpendicular distance. That will give us the radius. So we'll sub that into the formula, so the general form's on top, substitute in the point I'm interested in, 1, 4, over the Pythagoras' theorem, and we come up with our answer. Well, that simplifies down, doesn't it? That's just 5 units. I now know the length of the radius, I know the centre, so I've got the equation of the circle. X minus 1 squared plus y minus 4 squared is 25. If we just look at the general solution of the equation, if I substitute in, it's either going to give me 0 if it lies on the line, or it'll give me a positive number, or it might give me a negative number. But what does that mean? Now think about when you're drawing regions in the plane. If I had said to you, hey, I want you to shade where this is greater than 0, you would have shaded one side of the line. Another way to think about that is, if I substitute into the equation and I get a positive answer, I know it must be on this side of the line. And if it gave me a negative answer, it must be on the other side of the line. So if I wanted, for some reason, to investigate 2 points, I could determine which side of the line they're on, and whether they're on the same side or on opposite sides. How about this sort of question then? I want to find the equation of a line that goes through the point, a particular point, but also the intersection of some other 2 lines. How could I do it? This sort of question I'm talking about. I've got 2 lines and I've got the point 1, 2, and I want to find the line that goes through the point of intersection of those 2 lines and 1, 2. So what have I got to do? Well, I've got to find the point of intersection, solve them simultaneously, and eventually, here we go, x is -2, y turns out to be 3. I now have 2 points, so I could find it. Well, let's find the slope joining those 2 points. It's -1/3. Now I could use the point slope formula and I get the answer. That may well be the way a lot of people would do. But there actually is a quicker way if we play around with it. I claim that it should be in that form, the answer. It might not look like a straight line, but if you look, it satisfies it. Because what was our general form? We had something times x. Alright, I've split it into 2 bits, but I have got that. A1 times Ka2x. So I've got something times x. Something times y. Yeah, I've got that. B1 K, B2 is y, and then some constant number, which in this case is C1 plus KC2. So it satisfies our definition of a line. That is definitely a line. The point of intersection of those 2 lines, if I was to substitute it into just the first line, it must give me 0, because it's on that line. But if I was to substitute it into the other line, I must also get 0, because it lies on that line. Well, therefore, that's the equation of the line I'm looking for. All I've got to do is find K. So for our example, I don't know what K is, but I know the 2 lines that are intersecting, so I'll write those down. It doesn't matter which one I multiply by K, I'll just multiply one of them by K. How do I find K? But remember, we've given another point that lies on that line. So if I substitute that in, I can get the value of K. And in this one, -5 on 4. I've now got the equation of my line. It's a bit messy, but that is a line. Let's tidy it up to make it look like what we're used to seeing. I'll multiply everything by 4, pull everything together. There's a common factor of 7 in there. I was going to say, that's not what we got before. There's a common factor of 7 in there. Divide by 7 and we get the answer. A bit less work than what we had to go through before. But again, it's using that idea of patterns. What do I see? So, handful of questions out of 7E, but also I've copied some HSC questions from the old course actually, so they're quite old questions, but just on playing with geometry, or Cartesian geometry more to the point.